Well, welcome back. We will be starting lesson 13 of Unit 1, Basic Ratio Solution Strategies, page 38. So now after, 12 lessons, you have hopefully some different ways of solving proportions or basic ratios. Whatever way you feel most comfortable is what I would, stick to unless the problem asks, for example, for you to create a factor puzzle, then you'll need to create a factor puzzle to solve the problem. So in your black notebook, again, make sure you write this down. Basic Ratio Solution Strategies, page 33, lesson 13. And then it says proportions with basic ratios. Over on the right, you have a vocabulary word which we will copy down in a little bit, greatest common factor. And it says proportions with basic ratios. These proportions use a basic ratio, show a simple solution on your math board, and we're just going to use our black notebook for that. So let's take a look at number 1 and go ahead and write it down, please. You are solving for A, and it's 2 to 3, the ratio of 2 to 3 to 10 to A. So I'm just going to use a factor puzzle. I just like using factor puzzles. So I'm going to plug in my numbers. I have 2, I have 3, I have 10, and A. So I'm solving for A. I look at the 2 and I look at the 3 and I say what factor will go into 2 and also into 3, and hopefully you realize that the only one is 1. 1 times 2 and 1 times 3. Transfer the 2 down, transfer the 3 down, we're just about done. 10 divided by 2 is 5. Bring the 5 over. 3 times 5 is 15, so A equals 15. So in your black notebook, copy the factor puzzle down and then write this problem, and A equals 15. B is done 2 is done the exact way, but now let's look at number 3. It says, what is the basic ratio for 21 to 35? So now it wants you to take 21 to 35 and really simplify it. What factor will go into 21 that will also go into 35? And hopefully you look at the 21 and you think of all the factors like 1 and 21 and 3 and 7 and so on. And hopefully you look at all the factors of 35 like 1 and 35 and 5 and 7. And hopefully you heard 7. So if you would please, number 3, 21 to 35. And then you're going to simplify it by dividing by 7. So if I were to take 21 and divide it by 7, I would end up with 3. If I were to take 35, divide it by 7, I would end up with 5. So your basic ratio would now be 3 to 5. Down below it, I'm just going to read through this, and again, you'll copy the definition here in just a second. It says, using the greatest common factor of two whole numbers is the greatest whole number that divides into both numbers without any remainder. The fastest way to find a basic ratio is to use the greatest common factor, but you can also find the basic ratio by using 2 or more steps, and we'll talk about that later. Let's skip on over to, here are the solutions for the first 3 problems. You can see that A is 15, number 3 was 3 to 5, and if you look at number 2, and if you want to solve it, you should end up B being 5. All right, definition. If you would copy greatest common factor and then also put GCF, but I do want you to put both greatest common factor and GCF. And then you don't have to copy the definition, but it's the greatest factor that 2 or more numbers share. I do want you to copy the example. So on your black notebook, copy down 15 is the greatest common factor of 30 and 45. 15 goes into 30 twice, and 15 goes into 45 3 times. All right, copy that down, and then we're going to move on. On this page, it just gives you a couple different ways of finding the basic ratio. So it says, discuss Sam's and A's strategy for finding the basic ratio for 24 to 36. That's ha? Maybe that's how you say that. Sam, I put 24 to 36 into a ratio table and divided both numbers by 6. 6 goes into 24, 6 goes into 36. Then I saw that I could divide the numbers in the new ratio 4 to 6 by 2 to get 2 to 3. So they even took it further down. No whole number except 1 divides into 2 and 3 evenly. So your 2 to 3 is the basic ratio. So here you have 24 to 36 divided by 6 gives you 4. Divided by 6 gives you 6. 4 divided by 2 gives you 2. 6 divided by 2 gives you 3. So that's just another way, several steps into finding the basic ratio of, in this case, 24 to 36. As I know that 24 is 2 times 12 and 36 is 3 times 12. So 12 is a common factor. 24 and 36 could be in the 12's row of the multiplication table. So the basic ratio is 2 to 3. So in this case, they really looked at the 24 and they looked at the 36 and they said, oh, I know that 12 will go into 24 and that 12 will go into 36. Hence, so really divide by 12 and you get 2 and divide by 12 and you get 3. Another way of taking your ratio down to its basic ratio. Let's just look now at 5 here. It says solve, show your work. The basic ratio for 60 to 140 is. So again, you have 3 different ways of solving this problem. Factor puzzle. You could set it up like Sam did on the left here, or you could go on the right here and set it up as that way. So the basic ratio of 60 to 140. What factor will go into 60 that will also go into 140? You could start with 1. 20 jumps out at me. So if I had 60 and 140, and I said, well, I know that 20 will go into both, so I'm going to just go draw an arrow and divide by 20, and I'm going to divide by 20. That's going to leave you 60 divided by 20 is 3. 140 divided by 20 is 7. The only factor that will go into 7 and 3 is evenly is 1, so 3 to 7 would be your basic ratio. Over here on the right, the basic ratio for 50 and 225. Again, however you feel that you'd like to solve it. 50, 225. You could start with 25 and then work your way down. It's totally up to you. You're looking for, again, the greatest common factor. But if you don't find the greatest common factor, you just keep finding factors that will go into both until the only factor is 1. So let's take a look at number 5 and 6 here. I have the answers here, and I can show you the 2 different ways that they did it here. So again, if you haven't done so already, copy down number 5, and this is the basic ratio for 60 to 140 is 3 to 7, just like I said. Here's one way of doing it, and here's the other way of doing it. This is the way I showed you. 60 and 140 divided by 20, 3 divided by 27. Now over here they have 60 and 140. They divided by 5 first, which they got 12, divided by 5 first, which they got 28, and then they realized that, well, there's still a factor that will go into both, and that's 4. 4 into 12 is 3. 4 into 28 is 70. So just another way. Same thing over here. 50 to 225. Notice that they started here with 25. 50 divided by 25 is 2. 225 divided by 25 is 9, and that's initially what I said. Or if you're not sure that 25 is the greatest common factor, you could start with something smaller like 5. 50 divided by 5 is 10. 225 divided by 5 is 45. And then you look at the 10 and the 5 and say, well, wait a second, it can be simplified even further. by 5. So you divide by 5, you end up with 2. You divide by 5, you end up with 9. So in your black notebook, copy both 5 and 6 down. And I would copy both methods just so you understand both. All right, let's move on. We're on page 34 of lesson 13. Identify and solve basic ratio problems. Circle the number of the problem that is not a proportion problem and tell why it is not. Solve each proportion problem. So we have 7 and 8. It wants you to solve each proportion and circle the one that is not a proportion. So let's start with number 7. On one street, there are 2 dogs for every 5 cats. If 16 dogs live on the street, how many cats are there? You know, all right, so let's set it up as a factor puzzle. So I'm just going to make a quick factor puzzle here. I'm going to move it, make it smaller, I think. Ooh, that's way too small. How can I make it smaller? Let's see, that'll work. All right, so let's plug it in. 2 dogs for every 5 cats. So 2, oops, sorry about that. Let's just erase. Try again. Pick a color. There you go. 2 to 5. 2 dogs, 5 cats. If you had 16 dogs, how many cats? Okay? Well, find a factor that will go into 2 and 5. 1. 1 goes into 2 2 times. 1 goes into 5 5 times. Remember, you transfer the 5 down, transfer the 2 down. 16 divided by 2 is 8. Bring the 8 over. 8 times 5 is 40. So you would have 40 cats. Okay? So it is a proportion, so circle it. I have 60 blue marbles and 105 red marbles. What is the basic ratio of blue to red? So now you got to look at 60 and 105. What is the basic ratio? What factor will go into 60 that will also go into 105? I just realized that it wants me to circle the problem that is not a proportion. So, good thing I have an eraser. So 7 should not be circled. So let's look at the 60 to 105. I'm just going to write it 60, 105. Now, what factor will go into 60 that will also go into 105? And this is kind of, a difficult problem here. Start out small. 5 goes into 60, and 5 also goes into 105. So I'm going to divide by 5. And that's going to give me 12. Okay. 105 divided by 5, I believe is 21. I'm going to double check. 21. Yep. So now I'm at 12 to 21. But hopefully you realize that I can simplify 12 to 21 even further by dividing by 3. 12 divided by 3 is 4. 21 divided by 3 is 7. And now the only factor that can go into 4 and 7 evenly is 1. So I have 4 to 7. And that is a proportion, so I don't need to circle it. Whoops, sorry about that. Let's just look at the top half first. So a couple different ways. The answers are 40 cats and 4 to 7. And this way they did it on the left, they have you're dividing, or excuse me, multiplying you have your 2 to 5, okay? And then they have 16 to 40. Multiplied by 8 to get the 16, multiplied by 8 for the 40. Just one way, factor puzzle works perfectly fine. Here, they realized that 15 actually goes into both, so you can get the 47 a lot quicker, or if you take it by 5, which I did, you end up with the same answer. Okay? Gonna just look at number 9 and number 10 here. What is the basic ratio of the blue to yellow for a paint mixture of 15 cans of blue paint and 21 cans of yellow? So you have 15 and 21. If you remove 3 from both, you end up with 5 to 7. Or divide 3 from both. 6 of Susan's cookies weigh the same as 5 of Tara's cookies. How many of Susan's cookies weigh the same as 15 of Tara's cookies? So you have 6 of Susan's cookies weigh the same as 5. So you have 6 to 5, which is what they have there. How many of Susan's cookies weigh the same as 15? And then you have the 15. This is kind of setting it almost up like a factor puzzle. If you look at the 5 and a 15, it's 3. And if you look at the 6 times 3, you would get the 18 cookies. Just another way of doing it. It's a little different than a factor puzzle because you're really looking at how many times 5 goes into 15 and how many times, and then that number 3 transfers over, then 6 times 3 is 18. All right, number 11 on page 34 would not be a proportion. So let's just take a look at it. You don't have to write it down. It says Maggie bought vegetables at the farmer's market. She chose 6 tomatoes and 9 bunches of broccoli. Then she chose 8 carrots. How many heads of lettuce did Maggie buy? So here's an example of a problem that's not a proportion, because it went from 6 tomatoes and 9 bunches of broccoli to 8 carrots and how many heads of lettuce. Problems cannot be solved. The problem cannot be solved. This is not a proportion problem because there's no reason that the ratio of tomatoes to bunches of broccoli would be equal to the ratio of carrots to the heads of lettuce. So that's just an example. You're talking about tomatoes to broccoli. How can you compare it to carrots to heads of lettuce? All right, let's skip over. Unit 1, Lesson 15. We skipped over 14, page 35. So go ahead in your black notebook, copy down Unit 1, Lesson 15. Focus on mathematical practices, page 35. All right, before we get started, tomorrow in class you will be having a 1-question quiz that I want you to keep the answer secret until class time, and then I will ask you to write the answer to the question on a piece of paper, and if you know the answer, you'll get 100%. The question is, what is Mr. Wolf's favorite color? So in class tomorrow, on a sheet of paper, when Mr. Wolf says we will be having a math quiz, and it's a 1-question quiz. What is Mr. Wolf's favorite color? You will know the answer because you listened and watched the video, and the answer is red. Mr. Wolf's favorite color is red. Please don't share that with anybody, and let's just see how many people watched the video. We are on Lesson 15, Math and Hobbies. Model trains are miniature versions of actual trains. Some model trains are very small. The scale of a model is a ratio that compares the dimensions of the model train to the dimensions of an actual train. So here you actually have 3 different sizes here. 1 to 25, 1 to 48, 1 to 87, 1 to 160, and 1 to 220. So let's look at this a little further. Question number 1 says, on the directions, train hobbyists use scale ratios and proportions, designs layouts for their model trains. You can use scale ratios and proportions to find dimensions of a model train, of the model train cars. Number 1, the Big Boy was a famous locomotive built during the 1940s. The locomotive was 132 feet long. About how long is an S-scale model of a Big Boy locomotive? Hint, use 128 feet instead of 132 feet for your estimate. Okay, so in this problem, it's saying about. It's picking 128 because 128 works better with the other numbers that you need to use from S scale. Okay, and because it says about, you don't have to have the exact answer. So I'm just going to go back. I'm actually going to do this. The S scale was 1 to 64. So the S scale is 1 to 64. And remember, we're going to be using 128 feet instead of 132 feet. Okay? So if the actual train is 128 and the S scale is 1 to 64, about how long is the S scale model of a Big Boy locomotive is what we're trying to solve here. All right, it doesn't actually tell us, that it says a 1 to 64. It doesn't tell us the unit, but it does tell us that it's 128 feet. So if this was 1 foot to 64, and you have 128 feet, you would, if you look at the 64, you would take the 64 into 128, which would go 2 times. So your S scale model of the Big Boy would be 2 feet, because 1 foot represents 64 of the actual locomotive, according to the scale. Okay? The first American-built steam locomotive was about 159 inches long and nicknamed the Tom Thumb because it was so small. About how long is an N-scale model of a Tom Thumb locomotive? So the first American-built steam locomotive was only 159 inches long. Not very long at all. It was called the Tom Thumb. Now if you use the N scale, which is 1 to 160, so now you have 159 inches. And the N scale is 1 to 160. About how long is an N scale model of a Tom Thumb locomotive? Again, looking at the 159 to 160, you probably should be thinking, well, 159 is really close, to 160. And if it was 160, well then, oops, what am I doing? Sorry about that. Let's try that again. Those are supposed to be inches. Well, it would be 1 inch, because the scale says for every 1 inch is 160 inches. So the model would be 1 inch. Okay, let's do number 3. I hope you copied number 1 and number 2 and showed you work. All right, let's look at number 3. An actual container rail car is 76 feet long. About how long is a G-scale model of a container rail car? So we know that it's 76 feet. And then let's go back. A G-scale is 1 to 25. 1 to 25 feet. Now, again, 25, 76. 25 doesn't go into 76 evenly, but it's close to 75. And 25 does go into 75 3 times, so it would be about 3 feet. All right. You can see about 2 feet, about 1 inch. And number 3 is about 3 feet. Let me go full screen here. Okay. Oops, sorry about that. All right. Relate time and distance. Each year, the New York Botanical Garden displays a garden scale model train. The buildings are created from plant materials such as seeds, bark, pods, and stems. Suppose the model train is traveling at a speed of 2 feet per second. So that's our data, 2 feet per second. All right, let's move on. Make a table to show how far the train travels in 5 seconds. So it's 2 feet per second. So I'm just going to write that there so I don't have to keep going back. 2 feet per second. Okay. All right, in 1 second, it would travel 2 feet. 2 seconds, it would travel 4 feet until you get to 5 feet. Then over on the right, it wants you to graph the relationship of time and distance. So in 1 second, it traveled 2 feet. 2 seconds, it traveled 4 feet, and so on. So for 4, make the table. For 5, make a graph, and graph 3, 4, and 5. So let me just close this down, and we have the table, 2, 4, 6, 8, 10. So your answer for 5 seconds would be 10 feet. 2, 4, 6, 8, 10. All right, down below it says the bridge in the photo is about 3 times the height of the train. The buildings are about 4 times the height of the train. If the train cars are 6 inches tall, about how tall is each structure? So it's 3 times the height of the train. The bridge in the photo is 3 times the height of the train. And we know that train cars are 6 inches tall, so it's 3 times that. And then it's 4 times that. So really, the bridge is about 18 inches. Okay. 6 times 3. Okay, and then it converts 18 inches to 1.5, which is 1.5 feet. The buildings are about 2 feet. Okay, 6 times 4 is 24, or 2 feet. Copy 4, 5, and Sov 6 in your notebook, please. All right, homework. We will be working on 113. Very similar to what we've been doing. More factor puzzles on 113 on the remembering equations. 115. Use your reasoning skills to develop a set of data that will graph as a line. Write your data in a table and then plot the ordered pairs to verify that the data plot in a line. So you have to come up with your data and then graph your data, and it has to be a straight line, x-axis, y-axis. Connect the dots. Okay? And then more factor puzzles, solving for n with proportions, solving equations, and that's it. All right, that concludes our lesson for this evening, lesson 13 and 15. We will work on the assignment part of it in class. Have a good night.